What are we gonna do?
Yeah.
I guess you gotta find out.
Bruh.
Bruh.
Let me talk to you.
How's everyone doing? Good? Is this a different view? You're all in rows and columns. Okay. What were we doing on Friday? I know it's so long ago you were here. That's okay. We were looking at the mean, right? And what the mean is, so that was the middle of the data. What else were we looking at? Spread, which we called range. We're actually going to use that more today, but sort of the range of the data measured by, what's that? Oh. SD. What's SD? Standard deviation. Okay. So what you're going to remember is the mean and the standard deviation always go together. The mean is where the middle is. The standard deviation is how spread out the data is. But the mean is not the only way to measure the middle, right? There were two other measurements. What were they? The median and the mode. The mode is going to be reserved primarily. Oh, thank you. So I forgot about that part. The mode is primarily going to be reserved for qualitative data categories. And today we're going to talk about what goes with the median when we start talking about spread. And the range is one of those things that goes with the median. So it's going to be more about locating measures of position. There it is right here. I lost my tab. Okay. Let's maybe just get right into this. So doing with position, we divide the data into multiple pieces. We could do unlimited numbers, so we call those fractiles. Okay, you divide it in half, then there's two pieces. That's what the median does. What we're going to do is we're going to add some other measurements so that we're getting quartiles. Quartiles would be how many pieces? 4. There's 4 quarters in a dollar, so that's exactly what's going on. 4, we're going to divide our 100% of our data into 4 pieces. The median will be in half, and then, so that's half. And then if you take the bottom half and cut it in half, you get the bottom quartile, which will be Q1. Q2 will be the median, quarter 2. And then Q3 will be the upper half of it. And we're going to show you some data and see exactly how that works. Okay. So again, remember that the median was not really found with a calculation, but a location. So what's the first step we have to do with data to find the median? Smallest to greatest, put it in order, exactly. Otherwise it's meaningless. So here's some data, it's not in order. First thing we're going to do is put it in order. And I noticed, because we looked a little closer, that they have an error here. This is not 21, it should be 31. But if you take the data, put it in order, we find them, and this is 15 pieces of data, right? Odd number. So we find the piece that's exactly in the middle, and they helped us by making it bold. This number, there are 7 above and 7 below, so that's the median. We'll also call it the second quartile, and you'll see that makes a little more sense later on, or the median. And then the bottom part of the data now has 7 pieces, not including that median. And so we can find sort of what we think of as the median of the bottom half. The middle of the bottom half is 26, 3 below, 3 above, and we call that quartile 1. The top half has 7 pieces of data. Halfway through it is 35, right? 3 above, 3 below, and we'll call that quartile 3. And this is how we're going to analyze our data. But what we're going to use is what's called a 5-number summary. We've only got 3 numbers so far, right? What do you think might be the other 2 numbers? The min and the max. Good. Makes sense, doesn't it? So a lot of this stuff with math, someone just sat down and said, It makes a lot of sense. Some of the math does not make common sense. I'll be honest with you, but it works. But it's not necessarily obvious. But sometimes it is obvious. Okay, so far so good. What we're going to do to analyze this, so there's that 5-number summary. We can draw a graph with it. What we're going to do is see how our calculators, our TI-84s, and I think I've got them working a little bit better today. Incidentally, I wasn't recording when we did the last time because it was all over the place, but I did make a recording over the weekend. I've got it uploaded, but I don't have the links in there. But I will have Fridays. What we did on Friday will be uploaded. So if you had any questions on that, you can go back and review that. We are recording this, so it's all there. So we want to put this data into our calculator. Does anyone remember what's the button we push to put in data? Stat, right? Because we're doing statistics. So notice when I'm up here, when I click a button, it becomes red. And then also down in the key press history, you'll see the button. So you can kind of follow. So hit your stat button. And up here, we can either edit, calc, or test. What do we want to do first? Edit, which is put in our data. Okay, so I'm just going to hit enter. Hopefully you do the same. Now, I put this in last time, but you'll want to do this in list 1. If you have some numbers in, say, list 2 and 3, you could just go to the top, hit clear, and enter to get rid of them if they're bothering you. If they don't bother you, that's okay. If you put your list in list 1, you'll be okay. So notice I've got 34, 30, 31. So if you can enter all the values from this top list or the corrected one on the bottom, it doesn't matter. You don't have to have it in order, and we're going to see. But I want you, part of this is you have to learn how to use the TI-84 calculator. That's the tool we're going to be using. How many of you drive? Did you learn to drive just by sitting in the passenger seat all the time? No. I mean, you did a lot. I mean, you learned some things, but you had to eventually get in the driver's seat, right? Using these calculators, you're in the driver's seat. Watching me do it, you're in the passenger seat. So we want you trying things out. And again, we'll give you some time to work through these too. How are we doing on getting all those put in? Still need to see the data? I'd have you look at your notes, but they told me that the data in the notes is a little different. So we'll put these in. Mostly, I mean, it's nice that we'll match up answers, but mostly I want you to see the steps you're going to take because we're going to get the 5-number summary 2 different ways. And one is through the graph and one is through just the data values. Questions? We doing okay? And this becomes a major way. So being able to put in and get the mean and the standard deviation, that's important. Being able to get the median with the 5-number summary, that's going to be important. Those are going to be our 2 main ways of analyzing data in this class.
If you guys need any help, let me know. Call me over or
Okay. Most of you, are you at a place where you can go on? Next step? Okay. So next step, where'd it go? We want to calculate the 5-number summary. So we go back to stat and we can go over to calc. And this is one variable statistics. This is exactly the same thing we did to get the mean and standard deviations. So we just hit enter. So notice I have my calculator set up to look like more like most of yours. Some of you have 3 steps after this. All you have to do is hit enter, enter, enter. The default is it goes to list 1, but I'm going to show you, maybe you wanted to use list 2 or 3. So if you notice L1, L2, L3 is right here. They're shifted values from these numbers. So what I'm going to do is I'm going to hit second, number 1, and notice that gives me, it's going to, I'm definitely sure I'm doing my stats on list 1 now. Okay. And again, if you've got the newer version of the software, that might already be a default. But you could also change it to list 2 because sometimes we're going to analyze 2 or 3 different datas. And you want to just put them in once and then be able to go back and forth. And then what do? We hit enter. What is this first number, X bar? What's that significance? That was from Friday. What do we call that? The mean, right? That's the mean. It's the sample mean also, okay? And then there's standard deviations here. The numbers we want, notice there's this arrow. There's the minimum. There's a Q1, and we have to arrow down, and we get the other numbers. And notice we can't go out any further. So we get our 5-number summary, 24, 26, 31, 35, and 39, which are the same numbers we got when we put it all together and then located the middle of the bottom half, the middle of the top half, the lower and the higher. Okay, so a number of reasons. So invalid dimension. Got all your stat plots off, that's good. Your data, oh, there's no data in there. So yeah, you have to, yeah. So you may run into some errors. And this is, again, this is a place where it gets a little messy to try to do it all together, but if you can, they don't have to be in order, no. Would you like to see another way we can get these same values along with the graph? Okay. Notice above the y equals, if you've used these before, that's usually where you put your equations for graphing. I want to show you, I don't have anything in here, which is good, because otherwise it might show up on the graph. What I want to do is I want to turn a stat plot, right? We're doing statistics. So I'll do second stat plot, and most of yours are probably all turned off, right? So this Y, I want to do a shifted Y, second stat plot. I get my plots. This one's turned on, but I could easily turn it off. Okay. So that's how you turn your stat plots on and off. Notice all the different types of plots we can do. We can do scatter plots, which we will do later, not now. This is a trend plot. There's a histogram. This works great if we're using the mean and the standard deviation. There are 2 box plots. We want the second one. So if you come down to type, you want to arrow over to the second one and hit enter so that it's darkened. So that it's darkened. And then the list we want it to come from is list 1. Now you might want to change that at some time. If you put your data in list 2, you would put list 2 there. Each one has a frequency of 1. Mine is going to be blue. Yours, you might not have that color choice. So far, so good. Okay. How do we see that? Well, we want to graph it. Where we're going to go first, though, is we're going to go zoom and down to number 9, which is zoom stat. What that does is the calculator looks at what your data is and it fits it all into a nice little window. If you don't do that, you might not see your whole box plot. You hit enter and look at the beautiful thing that was drawn for you. Is that what you got that? Sure. Let's see, what did I do? Okay. So I went to stat plot make sure one of them's turned on and the other one should be off because otherwise it might not work. Make sure you've chosen the right type of graph, which for what we're doing now, we want the box plot. We're using list one, and then I go to zoom, and I could just hit the number 9 or I can arrow down to it. Some of your windows stop at 7, so just hit number 9, and that will zoom fit it. And now we've got a box plot. Now you don't see the numbers, but if you hit the trace button, look at this. It goes on and it will tell us that the median is 31, and this little butterfly guy's there, right? And if you go to the left, you get Q2, which is 26. You get the minimum, which is 24. Okay, so you can pick up your 5-number summary right from here. The nice thing about this is you also see what the data spread out looks like. Okay, so this I kind of like to you don't have to even go to all the list of numbers. Sometimes it's a little overkill, but this is it. And if I had 2 sets of data that I wanted to compare, and I had list 1 and list 2, I can actually have 2 of these, one above the other, and I can easily compare the data. Which one's more spread out? Which one is where the means are, and all that kind of stuff. I would have another one right underneath it. Maybe like with that paint, what we did, brand A versus brand B. How are we doing so far? Is it working? Sorta? Okay. Okay. All right. The next part we can do when we've done this, we talked about something called an outlier. What's an outlier? An extreme value. It's like way out there. You would be able to see these with a box and whisker plot because it would be way out there. But it is sort of officially defined as being what we do to calculate that is we look at what's called the interquartile range. And what that means is the length of the box, right? Q3 minus Q1. Take that length and then multiply it by 1.5. So not 2, it's not 2 box, but it's 1.5 box lengths. And that's what we define as being an outlier. We would add that number to Q3 to see how outlier at the far upper end, and we would subtract it from Q1 to see an outlier on the far lower end. Okay, does that make sense? And anything that's more than 1.5 of those interquartile ranges would be considered an outlier. Okay, so let's use this previous data that we just used. And just to remind us, Q3 was 35 and Q1 was 26. So how do we get the interquartile range? IQR. We're going to have 35 minus 26, which is, help me out here, 35 minus 26, 9. Then what do we do with the 9? Multiply it by 1.5. 9 times 1.5. What's that? 13.5? Or is it 12.5? Okay. No, you're right, 13.5. Yeah. So what do we do with that? Well, to see if there's any outliers on the high end, we take 35 plus 13.5. And that's going to give us 48.5. Was there any data that was bigger than 48.5? Go back. Our biggest piece of data was 39, right? So there's no data, there's no outliers at the high end. And then what do we get to for the low end? Subtract 13.5 from 26. And that's going to give us what, about 12.5? Does anyone remember what was the smallest piece of data? 24. We don't have any outliers on the bottom end. If we did have something that was like 10, that would be an outlier, right? Anything 12.5 or less would be an outlier. Make sense? Okay, so that's a way we can find outliers using median and the 5-number summary. Box and whisker plot. And again, using these TI-84 calculators, we're going to be able to analyze everything graphically and numerically as well. Good? Okay. Box and whisker plots. So we'll just talk a little bit about this. The way you can make it, basically, if you've got that 5-number summary, you can put it out on a number line, but the calculator also handles it for us. One thing I want to highlight, if we were given a 5-number summary, it's going to do that anyway. So notice you can just take your 5 numbers. I think I better order a new cable. I don't know why, although it doesn't do it at the other place. Anyway, 19 is the smallest, 47 is Q1, 55 median, 58.5 Q3, 61 is the highest. Do you see, can you visually see whether there's outliers there or not? Are there any outliers at the higher end? Why not? Or someone say no. Interquartile range is this much, right? If you added that much onto the end, right, you'd be up to here. No outliers, right? Actually, you have to add that plus a half, so you'd actually be out to here, right? Interquartile range, so add that distance plus half that distance. It's about here. Anything below that is an outlier, right? So we know definitely 19 is an outlier. There might be some others because we don't see all the data, but anything below whatever this is, and again, we could calculate it, but with the box and whisker, you can also visually see, are there outliers or not? Why is that important? We talked about which of the measures of central tendency, the mean or the median, which one is better when we have outliers? Which one is less affected by outliers? The median, right, because remember, outliers pull the mean towards them. So this is a skewed distribution because it's got an outlier. Using the median is the best way to analyze this. Otherwise, what's going to happen is the mean is going to get pulled this direction. So this is going to be left skewed data because it's got an outlier on the left side. So using the median is the best way. That's part of what we want you to be able to do is as we get data, we're going to ask you, how should we analyze this? This data should definitely be with a 5-number summary in the box plot. If we don't have outliers, then it makes sense to use the mean and the standard deviation. So sometimes we analyze it both ways and we say, okay, which one should we really use? This one, median. The one we had before where there were no outliers, let's go with the mean and standard deviation because that's got some other tools we can use and so forth. Okay. We're going to end up here. So we've used quartiles. Now we're going to look at something dealing more with percentiles, which is dividing things into 100 pieces. Okay. Mostly looking at percentages. Okay. So now, so we're transitioning. We're not using the median anymore. We're looking at data that would fit nicely in a symmetric curve, that nice bell-shaped curve we've been using. And what we're going to use is the z-score. And again, we'll use that a little bit down the road, but we want you to know how to calculate it. What is the z-score? The letter Z comes from the German word for integer, which starts with a Z. I don't know, I can't remember what it is, but so that's why they call it a z-score, because they developed a lot of this in Germany. Okay, and so the z-score is simply, you're going to take the population mean, you're going to subtract it from a data value, and we'll do a couple of these, and you're going to divide it by the standard deviation. Okay, and that will give us a z-score. And what a z-score is, it tells us how many standard deviations it is. How far from the mean is it? So let's do this calculation with this information. So first, we were told we're on a stretch of highway. We calculate a mean speed for the vehicles of 56 miles per hour. That's the mean. The standard deviation is given to us is 4 miles per hour. And we got 3 other cars, one at 62, one at 47, and one at 56. What we want to do is calculate the z-scores for each of these. So remember, the z-score is the data value minus the mean divided by the standard deviation. So what we want you to do, some of you calculate 62, 47, and 56. And what I'm going to do, how about this side of the room, if you can do the calculation when x equals 62. This row, if you could do when x equals 47. And if you guys could do when x equals 56. And we can get these calculated, and you'll each get a chance to calculate one of these. Okay. Again, we're using just this formula. You're putting in the value for x, subtracting 56 divided by 4, and that's going to give you the z values. How about over here? Anyone have an x is 62? 1.5. Very good. Notice it's positive, and why is it positive? 62 is above the mean, right? So you get a positive number. Those who were working on x equals 47, did you come up with a number? Negative 2.25. Notice 47 is below the mean, thus you get a negative number. And how about the last row? Anyone get what happens when x equals 56? 0. 56 minus 56 is 0. Divided by 4 is still 0. So when you're at the mean, your z-score is going to be 0. If you're above the mean, your z-score is going to be positive. And it will tell you, so this first one is 1.5 standard deviations away from the mean. The 47 is 2.225 standard deviations below the mean. Okay, so far so good. And what we can do is we can use sort of these z-scores to determine whether a data value is sort of a typical average, if it's in there, or if it's maybe an extreme value, kind of like an outlier. So let's divide off. How about to the right? You guys do the calculation for women's heights. So find the z-score here. And from this side, that over, find the z-score for the men's heights. So we've got the mean and the standard deviation. If a man or a woman is 6 foot tall, how many inches are they? 6 foot tall is how many inches? 72. Okay. If I stand up straight, I think I'm 70. I'm not 5'10". Sometimes I slouch a bit, so I'm either 5'9" or 5'10". Okay, 72 inches. So again, what is our calculation for z? It's whatever the data value is minus the mean, and notice these have different means, divided by the standard deviation. And then we're going to get that z-score, and that's going to tell us something about the data. So we've got the men. Women, you're going to calculate this, 72 minus a different mean, and divided by 0.6. What you're getting. Anyone got a value for me yet? So what are we getting? 2.96. Almost 3 standard deviations, right? Above the mean. For a woman to be 6 foot, that's there. How about for the men? 6 foot man, 0.7. Not even 1 standard deviation, less than 1 standard deviation. What we do when we're doing the z-scores, usual scores are between 2 standard deviations below to above. That's sort of like a typical value. If we're above 2 standard deviations, that's kind of unusual. And if we're above 3 or below 3, that's very unusual. So for a woman to be 6 foot tall with the z-scores almost 3 is right on that border between being an unusual to a very unusual. So, and that's just because, you see women's heights have a lower mean and a smaller standard deviation. So most women are about that. And there's, so we could say a 6 foot tall woman is we don't necessarily call it an outlier, but we say that's an unlikely value. But for a man to be 6 foot is not unlikely, at least according to this data. Could depend upon what community we're in. I know when I go to, I visited Thailand and they thought I was a basketball player because I was so tall. I said, I'm not really very tall from where I come from. I'm just average height, maybe a little bit below. But in Thailand, for that community, I was relatively tall. Make sense? Okay, so those are the things we want you working on. There's no more slides. The homework, I think I still have it. It has an initial due date of today. However, there's a secondary due date that will cover over the weekend. The goal is if you can get at least started and working through the homework all the way through, this is 2.5. If you can have that ready by tomorrow, what I will bring with me tomorrow is a practice test for chapter 2, just like we did with chapter 1. We can work through that, make sure, and work on homework. And then Thursday, we can have a review day, and I can put it all together, put chapter 1 and chapter 2 together, focus on any questions you have from that. And then on Friday, we would take the test for chapter 1 and 2, about 20 questions. Yes.
Tomorrow they have a senior meeting.
Ah.
So they're going to come in and check in. So they can come in and check in and they can come take the paper.
Okay.
And work on it on their own.
Perfect.
Okay. So any questions you guys might have to be addressed on Wednesday with me or on Thursday with them. So you guys do need to come and check in, and I'm free. I need to check you guys in. You guys pick up the paper, and then you guys can go to where it's is the helm or PAT? I think it must be PAT. Helm might be a little bit too small for all of the seniors.
Wow. And remember, try that practice test on your own. You can use your notes. Try it on your own, like 15 minutes. STEC on, go ahead and work with somebody else. We'll go over them as well. But just kind of see how much you know, how much you need to study, and we'll get you there. Okay, good. And then that's good that we'll have Thursday to come back.
It's the PAT, okay?
Okay. So go ahead and start working with your notes, maybe narrowing it down to maybe a 1 page of notes for chapter 2. Remember, you'll get 1 page front and back for notes for chapter 1 and 2 together. So we'll that's what we got to work on. Do the homework, page of notes. My goal, a little bit, but I think we can do it. My first goal is that everybody who's engaging is such that we have everyone passing the class. That means a C or better. But actually, I'd like a B or better. And I wouldn't mind if everyone got an A in the class. And I hope we can get there. And again, it's not something everybody gets an A. A lot, as you saw, the primary part of the grade is based on tests. But let's do it in a way, these practice tests, the tests will be much like the practice tests. So if you engage with all of those, the homework, practice tests, you should do very well on the tests. And you get your notes, remember? So as you go if you forget something, make sure you put it in those notes. And you're going to do just fine.